What is dependency injection in .NET Core? Dependency injection, DI in .NET Core is a design pattern used to achieve loose coupling between classes by removing the responsibility of creating dependent objects from the client class. Instead, dependencies are injected, by the .NET Core IOC, in version of control container. The problem: tight coupling. When a client class directly creates an instance of a service class, both become tightly coupled. This leads to difficult testing, hard to maintain code, poor flexibility when changing implementations. The solution: loose coupling with DI. Dependency injection solves this by using interfaces, abstractions, instead of concrete classes, letting the DI container create and manage service objects, injecting required dependencies into the client class automatically. Key components in DI. 1. Client class, consumer. The class that needs a service to perform its work.
2. Service interface, abstraction. Define what the service does, not how it does it.
3. Service implementation, concrete. Provides the actual logic for the interface. 4. DI container, IOC container. Built into .NET Core, it creates service objects, manages their lifetimes, injects them where needed. Service registration, programmed CS/startup.cs. Services are registered with a DI container using lifetime methods. Add transient IS. A new instance is created every time it's requested. Add scoped IS. One instance per request, commonly used in web applications. Add Singleton IS. A single instance is shared throughout the application lifetime. Constructor injection. The most common DI method in .NET Core is constructor injection. The client class receives its dependencies through its constructor, and the DI container supplies the correct service implementation at runtime. How the flow works. 1. Service interfaces and implementations are registered in the DI container. 2. The client class requests a dependency via its constructor. 3. The DI container resolves and injects the required service. 4. The client uses the service without knowing its concrete implementation. Benefits of dependency injection. Testability: easy to mock dependencies. Maintainability: code is easier to modify and extend. Flexibility: swap implementations with